Okay, today we're going to carry on our second day of notes dealing with simplifying radicals. Okay, and what we're going to see today is we're going to see radicals with variables. Okay, sometimes, and I underline this, sometimes you can simplify radical expressions that contain variables. Any variable that has an even exponent is always a perfect square. And that goes back to our properties of exponents. And I'll explain when we get down into the examples. Okay, so when you're simplifying a radical expression that has an even exponent, like I said, that means they're always a perfect square, so we're going to be able to take a square root of it nice and clean. And this is like the shortcut, the trick. Just divide the exponent by 2 and write the variable to that power outside the radical. That's it. Divide by 2 and write the variable to that power outside the radical. So if we see x squared, well, we could see it here. If you want to divide 2 by 2, 2 divided by 2 is 1, so that's x to the first outside. And why does that work? Well, I could show you here. I'm going to rewrite this as x. I'm going to put the x in parentheses to the second power. What we already learned last chapter is the square root and the exponent of 2 cancel each other out, so we're left with x. Okay, that's the longer way to do it. The shortcut, just divide by 2. So when we have the square root of x to the 8th, I can think of that as x to the 4th squared. Okay, so because when you raise a power to a power, you multiply the exponent, so that's x to the 8th. Now the square root gets rid of that exponent of 2, so I have x to the 4th. Or 8 divided by 2 is 4. So I'll use the shortcut here. 14 divided by 2 is 7. If you want to break that down, this would be x to the 7th squared, because when you raise a power to a power, you multiply. So this expression and this expression are exactly the same. The square root would get rid of that exponent of 2, and that would leave me with x to the 7th.